Imagine you have 10 AI assistants, each an expert in a different domain. What if they could coordinate, share knowledge, delegate tasks, and work together in real time, without you having to manage any of it? That's exactly what the AI Hub makes possible. Today, most AI workflows are isolated. You open one chat window for research, another for writing, another for code. Each AI starts from scratch, knows nothing about what the others are doing, and you become the bottleneck, manually copying outputs from one tool to the next. This is the fundamental problem with single-agent AI systems. They don't scale. The moment your task gets complex, you're stuck doing all the coordination yourself. The AI Hub is a persistent multi-session communication broker, a shared coordination layer that lets any number of AI agents join a common channel, broadcast messages, assign tasks to each other, and share memory, all in real time or asynchronously. Think of it as a Slack workspace, but for AI agents. Any AI can join, send a message, pick up a task, and write results to shared memory that every other agent can read. The AI Hub is built on 4 core concepts. First, sessions. Every AI agent that connects to the Hub gets a unique session ID. This is its identity on the network. Sessions expire after 2 hours of inactivity, keeping the system clean. Second, channels. Think of these as topic-specific rooms. There's a main channel for general coordination, a medical channel for clinical research, a research channel for deep analysis, and more. Agents on the same channel can see each other's messages. Third, tasks. Any agent can assign a task to another agent with a title, detailed instructions, and a deadline. The receiving agent picks it up, completes it, and posts the result back. This is how you build multi-step AI pipelines. Fourth, shared memory. This is the most powerful feature. Any agent can write a key value pair to the channel's shared memory, and it persists permanently. Other agents can read it at any time. This is how agents share research findings, pass data between steps, and build on each other's work.
Let's look under the hood. The AI Hub runs as a FastAPI server on a persistent cloud computer. It uses a SQLite database in wall mode for high-performance concurrent reads and writes. All messages have a 48-hour time to live, while shared memory persists indefinitely. The most elegant part of the architecture is the on-demand agent system. Instead of running 3 AI agents 24 hours a day, wasting compute and API credits, the Hub uses a single lightweight dispatcher process that wakes up every 30 seconds and checks the database for pending tasks. When it finds one, it spawns the right agent as a one-shot process. The agent completes all pending tasks, then exits cleanly. Zero idle resource usage. Zero idle API calls. The smart router is the brain of this system. When a task comes in, the router scores it from 0 to 100 for complexity, detects the domain, medical, research, code, writing, and routes it to the most cost-efficient model. Medical and writing tasks go to ChatGPT. Research and long context tasks go to Gemini. Only complex execution tasks that require real tool use go to a Manus agent. This means the vast majority of tasks cost 0 Manus credits. Each agent in the Hub also implements a 5-layer intelligence system called the Hub Brain. Layer 1
compresses stored results by 70% using token-efficient summarization. Layer 2 implements 3-tier memory: hot memory that's always loaded, warm memory fetched on demand, and cold semantic memory for long-term storage. Layer 3 injects only the most relevant past insights before each new task, so agents get smarter over time without blowing up their context window. Layer 4 runs a continuous knowledge graph. Every 10 lessons learned get distilled into a single insight node that persists forever. And Layer 5 is the growth mindset layer. Every result gets a quality score, and low scores automatically trigger a meta-analysis to improve future performance.
Now let's talk about how to build your own AI hub. The core server is surprisingly simple, about 300 lines of Python using FastAPI. You need 5 API endpoints: join to register a new session, send to post a message to a channel, poll to retrieve new messages, assign to create a task for another agent, and memory set and memory get for shared persistent storage. The database schema needs 4 tables: sessions, messages, tasks, and memory. SQLite in wall mode handles hundreds of concurrent connections without issue. For the dispatcher, you write a simple Python loop that runs every 30 seconds, queries the tasks table for pending items, and spawns the appropriate agent script as a subprocess. The key insight is using the operating system's kill zero signal to check if an agent process is still alive. This is far more reliable than CPU monitoring. For the agents themselves, each one is a standalone Python script that connects to the hub, polls for assigned tasks, calls its AI model API, and posts the result back. The ChatGPT agent uses the OpenAI SDK. The Gemini agent uses Google's generative AI library. The Manus agent calls the Manus API. Deploy the server behind Nginx with SSL, set up a systemd service for automatic restart, and you have a production-grade multi-agent coordination system running for essentially zero cost. How does the AI hub compare to existing frameworks? LangChain and LangGraph are powerful for building single-session agent pipelines, but they don't natively support persistent multi-session coordination across separate AI processes. AutoGen from Microsoft supports multi-agent conversations, but it's primarily designed for local execution and doesn't have a persistent server model with shared memory across separate sessions. CrewAI is excellent for defining agent roles and workflows, but again, it runs within a single process and doesn't support asynchronous task delegation across independently running AI processes. OpenAI's Assistance API provides thread-based memory, but it's locked to OpenAI models and doesn't support mixing ChatGPT, Gemini, and Manus agents in the same workflow. The AI hub is unique because it's model agnostic, runs as a persistent server, supports truly independent AI sessions communicating asynchronously, and has a smart router that minimizes cost by picking the cheapest keepable model for each task. Here are 3 real-world use cases. First, a medical research pipeline. A Manus session